All right, welcome to Chemistry Nomenclature for grade 10 Science, SNC2D. Today we're covering topics on naming chemical compounds and writing chemical formulae. We're going to start looking basically at elemental structures first, and then we will look at the elemental, and then we're going to look at compounds: ionic, multivalent, ionic polyatomic, ionic, and molecular/covalent. Okay, so that's what we're looking at first. And you want always to have near you, which would be good to have, is a periodic table. As well as a periodic table of ions. Okay, and we're going to start with the elemental piece first, okay? But before we do that, we're just going to review a couple of reviewing the difference between the atom versus a molecule. Okay, so an atom is basically one, and a molecule is more than one atom. Okay, it's more than one atom combined together. Okay, it's usually, there's a bond there. Okay, so you're either bonded through ionic structures or through covalent bonding, okay? And then we also have to remember there is elemental. Is it an element or is it a compound? And simply put, elemental is one type of atom, and a compound is more than one type of atom. In the pure substance. Okay, this is coming back from grade 9. If you remember, we talked about pure substances versus mixtures and elements versus compounds. And so when you're looking at that, you need to remember the way I look at it, is it on the periodic table? Can you find the name of it on the periodic table or the chemical formula on the periodic table just as one type? If you can, it's probably elemental. If it has more than one, I'll say more than one name or element in the formula. Okay, so here's some examples. I'm just going to use the chemical formulas right now. So if I write Mg, if I write O2, if I do CaCl2, when you look at that, Mg, well, that's found on the periodic table, so that's magnesium, and it's an atom, because there's only one of them. It's also an element. Okay? O2 contains one type of atom, so we can say it's elemental, but it's not a atom anymore. It is a molecule because it has more than one atom making it up. And CaCl2, it's made up of two different elements, so that makes it a compound. And all compounds are made up of more than one atom, so we know that it's also a molecule. Okay, so just as a review, you should understand the difference between atom and molecule. and between element and compound. So when we start talking about things, always have that in the back of your mind and how to plan for that when we look forward. So let's look at elemental things, okay? So if we're looking at an element, so we think of it as a flow chart. So let's start. Is it an element or is it a compound? So if it's an element, we'd say, yes, it is. And then we can break it down into a flow chart that says, is it one of these? Is it one of hydrogen, oxygen, fluorine, bromine, iodine, nitrogen, or chlorine, or as I like to call Hofbrinkel? If it's like that and it's by itself, we deem these as diatomic molecules. Which means when they're written alone, and again, this is alone, if they're written alone, and you see like an example, oxygen gas, well, it's written by itself as oxygen. It's written as O2 because it's a di, meaning two atoms molecule. Okay, hydrogen gas, it's H2. Okay? If it's not Hofbrinkel, then it's just written elemental. Okay, so it's just written elemental. So magnesium, sorry, this isn't writing nicely. Magnesium, when you write it out as in chemical formula, that would just be Mg. Or iron. Well, we write iron as Fe, because you can find Fe on the periodic table. So when you're looking at elements, if it's an element, yes, okay, is it Hofbrinkel? If it's one of the Hofbrinkels and it's all by itself, you write it as a diatomic. If it's not Hofbrinkel and it's elemental, then you would just write the chemical formula for what it is. Okay? All right, let's move on to ionic compounds. Okay? Okay, so when we're looking at ionic compounds, what we're looking at are compounds that exchange electrons in their bonds. Okay? It's usually a metal ion with a non-metal ion. Okay, so you've got a metal ion with a non-metal ion. And so when we're looking at that, if we're having to name, and when we form the compound, so when you do the formulas, is created by making sure the charges, the positive charges on the ion, equal the negative charges of the other ion. Okay, so the positive has to equal the negative. Okay, and in a previous lesson we talked about ions and how they're formed and whether they're gaining or losing electrons. And so this is how, when they lose the electrons, the other atom is now gaining them to form the other ion, okay? So when we name ionic compounds, when we name simple ionics, because we'll get to the name is pretty simple, okay? It's the metal name plus the non-metal ion name. So the metal ion name plus the non-metal ion name together. And the non-metal is basically the non-metal element name that ends with "ide." Okay? So when you start looking at that, you want to think of it as the metal ion name, which is just the metal name, and then the non-metal ion name, which is the non-metal, but it says "ide" at the end. Okay? So an example of that would be magnesium oxide. Okay? And magnesium oxide is made up of the metal ion magnesium and the non-metal ion of the ion of oxygen, which is oxide. So magnesium oxide is an example of a name for a simple ionic compound. So if we want to do the formula for that, so when we're writing chemical formulas for ions, we always have to remember the pluses equal the minuses, okay? And so we'll use the one from the previous one, so we'll use magnesium oxide. And if you look at your periodic table of ions, you will see that magnesium has a charge of 2+. Oxide has a charge of 2-. Okay? And we always go back to the pluses are to equal the minuses, so there's no charge. That's what our goal is. And since +2 equals -2 in the 2's, they're going to cancel each other out. So the new chemical formula for this will be MgO. So that's a pretty straightforward and simple way to look at it. Let's try a different one. Let's try magnesium. No, we'll use a different. Well, we can use magnesium again, I guess. Or let's look up calcium chloride. Okay, so we're doing calcium chloride. So find it on the periodic table, and you find calcium as the ion is 2+. Chloride is Cl. It has a -1 charge. Okay, and note, chloride by itself or oxide by itself is not oxygen, so it's not Hofbrinkel. But now the pluses don't equal, so the 2+ does not equal the -1. So we have to add at least another negative. So if we add another chloride, we now have another -1. So now we have -2 plus 2, they now equal. And so now when you write the formula, you have calcium, one of them, but there's 2 chlorides, so you have to put the 2 down there. And so you subscript the chloride so that there's 2 of them. So when you form those molecules, you'd have 3 atoms, 1 calcium and 2 chlorides, if that was the way it was to build, okay? We'll try one more that's a little more complicated. And let's do aluminum oxide. Okay, aluminum oxide, if you quickly looked at aluminum, aluminum is 3 plus, oxide is 2 minus. Those don't equal, so I need at least another oxide because I need 3, but now I have 4. And so if I go over to the aluminum, I need at least another aluminum, so I have to add another aluminum. So now I've got 3 plus. Oh, now I've got 6 on that side. And if you do it this way, like there's a crisscross method, but if you do it this way, you will always make the easiest choice to make the smallest number. And so if I do it that way, I can now say, oh, aluminum, I need 2 of those. And oxide, I need 3 of those. So writing ionic compounds for simple ionic is not as challenging as long as you have your charges equaling each other, and then you write with those subscripted coefficients what the numbers are. Okay, so that's the end of this lesson. The next lesson we'll be looking at multivalence and polyatomics, and then the final lesson will be on molecular/covalent compounds. Okay, I'm just trying to keep these lessons as short as possible. Remember, you can always email me and check with me if you have questions. Okay, we'll talk shortly into the next one, which is multivalent and polyatomics.